Guillaume, when people think of autonomous robots, they have this movie image, they think of sci-fi. But what does an autonomy engineer really do on the day-to-day in the real life?
Don't believe the movies. The real world is hard and messy. An autonomy engineer's job is to make a machine move from point A to point B while avoiding obstacles, without hitting obstacles, while staying safe, and above all, without getting lost, which is actually extremely hard to do indoors.
How do you get them to do it a million times over with that level of performance and with that level of accuracy?
Repeatability. This is where actually many projects crash against the wall of reality. In order to get there, you need to work with a team of people obsessed by everything that could go wrong, building many layers of redundancy. So if you have a failure, you can fall back to an acceptable behavior and above all, a behavior that is safe.
What would you say is the hardest problem in autonomy that people don't realize is actually that hard and impossible to really solve?
Actually, a problem that seems extremely simple, but it's localization and localization again. For a robot to be able to move, it needs to know where it is. You could think like, yeah, I have GPS, but no. Indoor, for everything that we do, we are indoor. We don't have access to a GPS. We kind of try to solve this challenge of localization with an added constraint, which is to not modify anything in the environment or to add anything in the infrastructure.
So what's your top piece of advice you'd give for someone wanting to be in the autonomous systems field or aspiring to get into the industry?
Smash walls. It's again half a joke. My number one piece of advice is to start as soon as possible to build empirical knowledge. A good autonomy engineer needs to face a couple of real-world issues in his career to understand and to build its empirical knowledge. And that you cannot learn it in the lab, you cannot learn it in simulation, even from the most simple and cheapest real physical system, but get out of the lab.
So we design, build the product, we work directly with customers, integrate with customers, make sure they get maximum value from what we're creating. How did it change the way you looked at autonomy, the way you looked at developing for this type of product within this environment?
I don't think we will be able to do what we do if we were not full stack, because autonomy, robotics is a very, very multidisciplinary field, and the way the mechanical part, the mechanical system is built will impact the accuracy of how it scans. So you need to be able to look at the system as a full stack, and if you just do it in isolation, it doesn't work with the same level of performance. And the level of performance we need to achieve at Dexory for our customer is the maximum that you can dream of. Without doing and controlling the full stack, we won't be able to do what we are doing.
That's one of the big decisions. We wanted to be able to control the technology that we bring to market, but also the speed at which we can operate, having the test environments, having all the resources available to move fast, iterate fast, and bring something impactful into the world.
The ability that we have to iterate overnight is unparalleled. Right? If you work with external supplier, or if like to build your mobile base, one change leads to a 2-month iteration. We can do an iteration overnight, literally.
Guillaume, thanks a lot. It's been really good speaking. If I were to sum this up, I would look to say what we're doing is hard, but the number one piece of advice for everyone operating in this field would be spend time with a real robot in a relevant environment and get your hands dirty. Build that practical, empirical knowledge. Did I miss anything?
No, that sums it up pretty well. I maybe can add that what we do is very hard, but because it's hard, it's extremely rewarding.